Hello everyone and welcome to another awesome learning experience with Sergio, who is awesome. Today we're going to be talking about the rate of change and slope. That's lesson 3.3, page 172 in your books. Hopefully I'll be able to help you do what you need to do in math. At the bottom, I just saw all that empty space and I was like, ew, we gotta fill it with something. So I just wrote filling empty space. But anyways, let's get started with the video. So the rate of change is a ratio that describes on average how much one quantity changes with respect to a change in another quantity. See, I wasn't that lazy today and I actually wrote it out for you guys, so be thankful. So the equation we're going to be using today is rate of change equals change in y over change in x. Okay, so use the table to find the rate of change and explain its meaning. So the number of computer games, the total cost. So what we need to do is we need to put the change in cost over the change in number of games. So if you look right here, the book actually uses these two numbers. So we'll do 156 minus 78, because that's the cost, over 4 minus 2, because that's the change of games. And we will get 39 over 1. So the rate of change is 39 over 1. So each game costs $39. Alright, so here's another one. The table shows how the tiled surface area changes with the number of floor tiles. So find the rate of change. So we can go ahead and take these numbers, put 96 minus 48 over 6 minus 3, and we'll get 16 minus 8 is 8, so 48 over 3, but I'm pretty sure that can be reduced. So let me see, 48 divided by 3 is 16. So 16 is the rate of change. And explain the meaning. Okay, so explain the meaning of the rate of change. So that means that for 16 inches squares of surface is tiled for each floor tile that is used. So that makes sense. Here. So 16 inches of surface is tiled for each floor tile. I think I just repeated exactly what I just said, but I felt like it would sound better if I did it again. I don't know. But that's the answer. So far you've seen rates of change that are constant. Many real-world situations involve rates of change that are not constant. So this graph shows the number of people who visited U.S. theme parks in recent years. Find the rates of change for 2000 to 2002 and 2002 to 2004. So for the first part, 2000 to 2002, we have to put the change in attendance, change in time. So if we look over there, 2000 you have 317 people and then 324 people. So we have to find like the difference. So we'll do 324 subtracting 317, 2002 minus 2000. That'll be the time. And we'll get 7 over 2, or 3.5. So over this 2-year period, attendance increased by 7 million for a rate of change of 3.5 million per year. Oh my word. Okay, so let's do the other one, 2002 to 2004. So that is 325, 324. So there was like a loss there. So let's go ahead and do it over here. 325 subtracting 324 over 2004 minus 2002. I will get 1 over 2 or 0.5. So over the 2-year period, attendance is increased by 1 million for a rate of change of 0.5 million per year. Alright, so for constant rates of change, determine whether each function is linear. Explain. if the change is constant, basically this is what you're going to do. If the pattern is like constant, the function is linear. If it's not linear. So you just got to look for a pattern. Okay, the next thing we're going to learn about is slope, which is a non-vertical line in ratio of the change in the y-coordinate to the change in the x-coordinate. So it's going to be slope equals rise over rung or y over x. And we're going to be using that equation a lot. Okay, so they want you to find the slope of this. So this means that what you're going to do is you're going to take your, these ones will match, and these ones will match. So you'll take your y's first, and so this is x1, y1, x2, y2. So you'll take your second y every single time and subtract your first y, and do the same with your x. Okay, and then you'll get 5. This will become a plus, so this is 3. And that's your slope of this line. Isn't that awesome? It's really simple, really easy. Okay, let's try another one. So this is x1, y1, x2, y2. Negative 3 minus 4 over 2 minus 3. This becomes negative 7. This becomes 5. That's your answer. Negative 7 over 5. It's so simple. Go ahead and do this one on your own, and when you're ready to check, unpause the video. Alright, so same thing. x1, y1, x2, y2. 8 minus 6 over 4 minus 3, 2 over 1. That is your answer. Or I could just say 2. That's the slope of the line. I like these, so we're going to do another one. Go ahead and solve this one, and when you're ready to check, unpause the video. Alright, so same thing. x1, y1, x2, y2. 10 minus 2, negative 2 minus 4, 8 plus, 8 over 2 plus 4, 2, or 4 over 1, or just 4. That's your answer. Alright, so sometimes when you're doing slope, you're going to find where it's going to be undefined. It just doesn't really make sense. So you're going to do the same thing. So x over 1, y1, x2, y2, 2 minus 3, 2 minus 4, negative 2, minus 2. Now this becomes negative 7 over 0, and this is undefined. So that's the answer, undefined. Let's do another one. So x1, it's actually probably really helpful if you write this on your paper. Just saying, this might be your undefined. That's your answer. So this is actually when you find coordinates given the slope. So when they give you it's going to be like a variable in there, and then you're just going to have to solve it. So the way that you're going to do this is you're going to write it just like you would an equation. So r, which is going to be your y2 minus 4 over negative 5 minus 1 equals 1 over 3. R minus 4 equals negative 6. That. And then you're going to multiply by 3 on this side, multiply by 3 on this side. So now you have 3 times r minus 4 equals negative 6. So So then doing distributive property, you would get 3r minus 12 equals negative 6. Then, now that you have 3r minus 12 equals 6, you just solve it like a regular problem. Oh, negative 6, sorry about that. So add 12, 3r equals 6, r equals 2. So now on that line where you had negative 5r, you can substitute it now as negative 5, 2, like that. Alright, so that's the end of the video. Thank you for tuning in. Hope that I was able to help you do what you need to do in math. It's been another awesome learning experience with Saoirse, who is awesome, telling you that you are awesome. Have a great day.